Now let us discuss about the union, intersection and difference of sets. We consider two sets, let us say A and B. Then A union B means the set of all elements that are in set A, in set B, or in both sets. Okay, so let's take an example. Let us suppose we have set A which consists of elements 1 and 2, and we have B set which consists of elements 2 and 3. Then A union B is a set, okay, the set of all elements that are in set A, which are in set B, or in both. So the union will be, so we have 1 here, we have 2 here, we have 2 here also, we will not include it, it gets repeated. So then we have 3. So this will be the A union B, the set of all elements that are present in set A, in set B, or in both the sets. So how do we show it within diagram? Let us suppose this is set A, it contains 1 and 2, 1 and 2. Then we have set B, it contains 2 and 3. Okay, so this is set A, this is set B, and it contains 3. Now what happens in union? We consider all the elements which are in set A. So this all area will be the union, which are in set B or which are present in both sets. Here you can see set A contains 1 and 2, set B contains 2 and 3. Then union will be the elements present in set A, which is 1, in this case 1 and 2, the elements present in set B, which is 2 and 3, and the elements which are both in A and B set. So we have 1, 2 and 3. Likewise, let us take example of A intersection B. Intersection is denoted by this inverted U symbol, the set of all elements that are common to the both sets A and B. Okay, now given this example, okay, if I draw it again, so what will be the intersection? The elements that are common to the both sets will be included in the intersection. So we have here 1 and 2. Okay, I am taking the first example. This is set A, this is set B. So A intersection B means the set of all elements that are common in both sets A and B. So here you can see only 2 is common to both the sets A and B. So this area, the elements present in this area will be the set of A intersection B, and here we will have only one element, which is 2. Okay, in A union B we have 1, 2 and 3. Now we have another A minus B, that is difference of sets, the set of all elements that are in set A but not in set B. Okay, now again taking this example, that means A minus B, A minus B. So let us draw this time the two sets again. So we have, let me draw it here. So we have A contains 1 and 2. Then we have B contains 2 and 3. Now the difference of sets is, the difference A minus B is the set of all elements that are in set A but not in set B. So since A is equal to, in A we have 1 and 2, in B we have 2 and 3. Now the difference is the set of all elements that are in set A but not in set B. So A minus B will be this very region. So this region. Okay, so A minus B will consist of element 1 only. Okay, then we have, I hope you got the idea what is meant by the union, intersection and difference of sets. So in the difference what we see, then the numbers or the elements that are present in set A but not in set B. Okay, so since B is this very, so we subtract, we have this set, from this we subtract this area. Okay, so only one element is present here. Now we take another set, what we call the universal set. Okay, if I have the space I can show it here, or for that let me rub this out. Now what is universal set? Now we have universal set. Universal set. Now universal set is the set of all elements under consideration in a given problem. So the set of all elements under consideration in a given in a given problem. Now let me rub this out. It is denoted by U, okay, or we denoted by A, the universal set. Let us denote it by E. Let us suppose we have a set universal which consists of elements 1, 2, 3, 4, 5, 6. Okay, this is our universal set. Now on the diagram we denote the universal set by the rectangle. So this universal set, so all the elements present in this rectangle represent the universal set here. So let us denote it by E here. And let's take another set. Let us suppose we have a set A which consists of elements 3, 4 and 5. Okay, now we need to define what is meant by the complement of a set. Okay, so complement of a set. Okay, by complement what we mean, the set that includes all elements, the set that includes all elements which are not in set A but still settle in the universal set. Okay, so complement is denoted by, if I have set A superscript C, so it denotes A complement or A prime. These are the denotions or notations for A complement. Now let's come to the question. So we have this universal set here, and we have a set in the universal set which contains 3, 4 and 5. So let us denote. So we have numbers 1, let us say 2, then we have 3, 4, 5, 6. So this is the universal set. Now in this universal set we have this subset which is A. Okay, now what happens here, since we need to find out the complement, that is A complement will be equal to, so A complement will be equal to, it will be equal to the universal set minus the elements present in set A. Okay, so simple thing, the set of all elements in a given universal set that are not in set A. Since we had denoted universal set by E, that is denoted by E here also. So what happens, all the elements that are not in set A but are still in the universal set, so that will be the A complement. So A complement will be this very region excluding the set A. So the numbers or the the elements in A complement will be 1, 2 and 6. So we will have 1, 2 and 6. They will be the A complement here. Now here we can also see some of the properties of the universal set here. Okay, briefly. So the union of set A, in this case the union of set A and the universal set gives us the universal set. Okay, so here you can see set A contains 3, 4, 5. Now union with the universal set, so universal set contains 1, 2, 3, 4, 5, 6. So the union will give us the universal set, that is the set of all elements which are present in set A, set E, which is universal set, or in both. So here it will be equal to 1, 2, 3, 4, 5, 6. So again we get the universal set. So this is A union universal set, it gives us the universal set in return. Okay, now another property of the universal set is that, or let me rub this out. The intersection of set A with the universal set gives us A. So A intersection, the universal set will give us A. So how do we show it? Since we know that in A we have 3, 4, 5 intersection. In universal set 1, 2, 3, 4, 5, 6. Now the common elements of A and E denotes our intersection. So here you can see A intersection E will be equal to, so the common elements are 3, 4, 5. Here we have 3, 4, 5, 3, 4, 5, and A intersection E will be equal to, so 3, 4, 5 is our A. Okay, so on the diagram, if I show it on the diagram, okay, let me take small diagram this time. So we have 1, 2, 3, 4, 5, 6. This time this is set A. Okay, this is set A and this is the universal set. Now this time A intersection universal set will be this region. Okay, so this A intersection E is equal to A.